Alright, this is Mr. Gillum, and today we're going to start learning about some theorems about parallel lines. And so the first thing I need to do is introduce you to some vocabulary so you know what I'm talking about when I'm trying to explain them. So let's start with that. And the first big word is going to be transversal. Transversal. Now, transversal, not looking at this earlier, a line intersecting two parallel lines, yes, that would be considered a transversal. Okay, so they even labeled this one T for us, but a transversal basically is the line that goes through the two lines you were talking about. It transverses two lines. Okay, we call that a transversal. It doesn't have to be parallel, but we'll just say lines instead. Okay, that's called a transversal. So, like for instance on transversal, this guy right here, we would call him the transversal of those two lines, where they intersect both of them. Okay. So if I refer to transversal, that's the line I'm referring to, specifically the one labeled T. But in this case, there are two types of angles, and like a diagram like this, we're looking at the line Q and the line R. Okay, the interior angles are the lines in between. So angle 4, angle 3, angle 3, angle 4, angle 5, and angle 6. Okay, those are all interior angles. The exterior angles are on the outside, so those would be considered angle 1, angle 2, angle 7, and angle 8. All right, so interior on the inside and exterior on the outside, basically. All right, so just a little bit of vocab so you know what I'm referring to. Consecutive interior angles are angles that are on the same sides of the transversal line. So I've got two diagrams this time. I'm going to show you over here, once again, since we already identified our transversal as this guy right here. Consecutive interior angles would be like angle 4 and angle 5. They're on the same side of the transversal line, and they're both interior angles. So we would pair angle 4 and angle 5 together. Or we could pair angle 3 and angle 6. They would also be consecutive interior angles. Okay, on this diagram, we should probably put for this guy so we're not confused. Consecutive interiors would be angle 3 and angle 5, or we could do angle 6 and angle 4. We'll put them in numerical order. Angle 4 and angle 6. Okay, so they have to both be on the interior and they both have to be on the same side of the transversal. And then we would have alternate interior angles. Okay, alternate interior angles. Non-adjacent interior angles that line up on opposite sides of the transversal. Whew. Okay, that was really long, confusing, but okay, here's how it works. Angle 5 and angle 3 will be alternate interior angles. They're on opposite sides of the transversal and they're not adjacent. Okay, call them alternate interior. So I'm going to put that one over here. So angle 3 and angle 5. Now I know I only put a couple diagrams in your notes, so make sure that if you're writing down these angle measures that you're referring to which diagram. You can call this one like diagram 1 and diagram 2 if you want. It doesn't matter to me. Just make sure it's clear to you. Also alternate interior angles on this one would be angle 6 and angle 4. That would be alternate interior. On this diagram, alternate interiors would be angle 3 and angle 6. They're both interior and they're not adjacent. And 5 and 4 would be alternate interior. Those would go together as well. Okay. I bet we have alternate exterior angles now. Alternate exteriors. So same idea. They're on the exterior, so on the outside, and they alternate on other sides of the transversal. Like that. So angle 2 and angle 8. And angle 7 and angle 1. They're alternate exterior angles. Okay, on the outside. And on this diagram, we would have, since these are the exterior angles, angle 1 and angle 8 would be alternate exterior. And angle 7 and angle 2. Alternate exterior. Exterior on the outside, alternating on other sides of the transversal. But you got to remember too, they're non-adjacent, so it's easy to confuse them. So like, for instance, angle 7 and angle 8 would not be alternate exterior angles because they're adjacent, and one of the qualifications is that they're not adjacent, non-adjacent. Okay, corresponding angles, one of my favorites. Corresponding angles would be angles that are on the same side of the transversal and on the same line of R. So see how the angle 2 is above line Q and above line R for angle 6, so they would be corresponding. Okay, and like angle 1 and angle 8 would be corresponding. It's above and above the line. Oh, not 8, not 8, not 8, not 8. Angle 5. Sorry, angle 1, angle 5. And then we would have like even angle 8 and angle 4 would be corresponding. Or angle 7 and angle 3. Okay, so over here, and this is where our theorems and postulates and things like that are going to come from when we have parallel lines. That's really what our emphasis is on. Angle 1 and angle 5 are corresponding. Or angle 3 and angle 7. Or angle 2 and angle 6. Or you could say angle 4 and angle 8. Okay, they're corresponding. They're on the same side of the transversal and on the same side of the line. So bottom half, 4 and 8 go together. So now we have a postulate, and these postulates you're going to find they all have something that are very similar. What you're going to notice is that there's a lot of congruencies. The postulate says if two parallel lines are crossed by a transversal, the corresponding angles will be congruent. So first things first, I don't see any markings for parallel. If you see those little arrows on the lines like that, that denotes that they are parallel. So we are going to say that line M and line N are parallel, and line T, our transversal, intersects both of them. Now, our postulate says that if the two parallel lines are crossed by a transversal, the corresponding angles are equal. So angle 1 is equal to angle 5. So when we start justifying our steps, this is going to be part of it right here. We know that these corresponding angles must be congruent. Or we know angle 2 must be equal to angle 6. Now this is only when two parallel lines are crossed by a transversal. Obviously in the last one this postulate wouldn't make sense because 2 and 6 are obviously not the same angle. Okay, so this postulate works only when you have two parallel lines crossed by a transversal. We could also do angle 4 is equal to angle 8, or angle 7 equals angle 3. Right? And so what you're going to do, and you can write this in, or write it somewhere at least, if I said that angle 1 is x plus 2, and I knew that angle 5 was 135 degrees, I said solve for x, I would know that angle 1 is equal to angle 5, so I could do x plus 2 equals 135, and I could solve for x and find what x is if that's what the question asked me to do. Okay, so corresponding angles. Very, very useful. I could do the same thing with 4 and 8 or whatever. But yeah, so corresponding angles postulate. Corresponding angles are congruent if a transversal crosses two parallel lines. Okay, let's use a different color now. Alternate interior angles theorem. Okay, alternate interior angles theorem. That says that if two parallel lines are crossed by a transversal, that the alternate interior angles are congruent once again. So there's all kinds of congruencies here. So if I look, let's just remember interior angles, I only have 4 of them, 3, 4, 5, and 6. Alternate interiors will be angle 3 and angle 6. So I know angle 3 must equal angle 6. Or I know that angle 5 is an interior, and it is an alternate interior with angle 4. They must be equal. Okay? So what's going to happen is they're going to ask you this question like, okay, well actually you know what, let's just prove, or let's not formally prove, but explain why this is the way it is. If I took the measure angle of 3 and I used what I know about vertical angles, it turns into angle 2. And if you look, angle 2 corresponds to angle 6. Therefore, angle 2 and angle 6 are congruent. So angle 3 and angle 6 must be congruent. So if there was, I might say we might have to use some transitive properties in our proofs here soon. But for now, for today, you're going to see more examples of something like angle 4 is 3x and angle 5 is, oh geez, okay, we'll say 99, something like that. And it's going to say something like find what x is. So you'll say, oh, okay, well, if they're alternate interior, which these are, they must be equal. So I can solve. Now, obviously, it's a little more than 99, but you get the idea. Okay, you get the idea. Alternate interior angles theorem. They are congruent. Alternate exterior angles theorem. Once again, we have exterior on the outside, and don't forget these are parallel. It says that the parallel lines are crossed by a transversal, then the alternate exterior angles are also congruent. So I would know that angle 7 and angle 2 are equal. And this only goes for if these lines are both parallel. Angle 8 and angle 1 are equal. And so the practice is going to give you is, and once again, I can show you again, look, angle 8 corresponds to angle 4. And angle 4 is vertical to angle 1. Therefore, angle 8 and angle 1 must be congruent. So, the problem you're going to see is going to be something like, oh, okay, here's angle 1 and it's 140 degrees, and we want to know what x equals. Well, that would be a really easy one. If these are alternate exterior angles, I would know that x has to equal 140. Okay, and they might throw some more tricky stuff in there, like find what x is if this guy would be 2x minus 1, for example. Well, then I would have to do a little more work. I'd have to say 140, well, that's not true. I wouldn't have to do more work at all. That's not a good example. They might give you x's over here, and they might say this guy is, I don't know, this guy's x and this guy's y. It might say find both variables. Well, you would know that x has to equal 140 because alternate exterior angles are congruent. And you would know that this guy is supplemental to y, so you could find 180 minus 140, leaving 40 for your y. Right there. So, okay, you get the idea. These theorems are going to be really handy. Once you get the lingo and the vocab, it won't be too bad for you. Consecutive interior angles. You're going to like this one. This one's a little different. It doesn't say anything about congruent, but it does say if two parallel lines cross by a transversal, so that's the key in all these parallel line angle theorems. There's two parallel lines always. Okay, consecutive angles are supplementary. We knew that. I mean, consecutive interior angles, look, they're right next to a line, and we know a line adds up to 180, so I know angle 3 plus angle 4 must equal 180 as well. Okay, so that's what I would say. I would say angle 3 plus angle 4 could equal 180, or angle 5 plus angle 6 could equal 180. And like I said, we're going to throw some variables in there, and you're going to have to figure out what goes where, but you get the idea. Okay? And then finally, the perpendicular transversal theorem, which is almost common sense as well, more or less common sense. It says if the transversal happens to be perpendicular, and it's perpendicular to one, then it must also be perpendicular to all the other parts. There's all right angles involved. Okay, right angle, right angle, right angle, right angle. All right angles, always. Okay, so if it's perpendicular to one line, that is parallel to another, it is therefore perpendicular to both of the lines. And that's it. That's all for today. And like I said, they're going to throw in some variables. You're going to have to solve for some angle lengths and that sort of thing. But I know you'll reference your notes, and if you have questions, I'm always there to help.